This is the world's largest Rubik's Cube mosaic. It has over 12,000 Rubik's Cubes, and compared to Michelangelo's actual The Creation of Adam, the images look super similar. But here's the crazy part, and part of why Rubik's Cube mosaics are so popular today. A Rubik's Cube only has 6 colors: red, orange, yellow, green, blue, and white. So how can Rubik's Cube mosaics, being restricted to just 6 colors, be able to show such intricate artworks? Well, let's start by zooming in on our input picture, our slightly pixelated Mona Lisa, to find just the first single pixel. Each pixel in an image has a red value, a green value, and a blue value, each ranging from 0 to 255. Increasing the red value will shift the color towards red, making the image seem warmer. For example, if we increase the red, or R value, to 255, the color will go from a brownish color to a peach color. Inversely, if we decrease the R value to 0, the color will lose red, becoming a sea green. The same thing happens if we change the green or the blue values, except the color shifts more or less towards the adjusted color. The total number of colors that could be represented by this RGB color space is 255 to the power of 3, or 16,581,375 possible colors. You can actually express an RGB value as a 3-dimensional coordinate, with x being r, y being g, and z being b. Therefore, you can find the distance from any one of these 16 million colors to any other color by using the 3-dimensional Euclidean distance formula. It is basically just a slight variation on the regular 2-dimensional distance formula with a third dimension added. Here's a more visual display of this 3-dimensional expansion. The distance between the 2 points in 3-dimensional space is just the length of this line. Now that we know how to find the distance between any color, we can go into how the first step of producing the mosaic occurs. Remembering that the Rubik's Cube has 6 colors, red, orange, yellow, green, blue, and white, we can plot the RGB values for the colors here. Now, using the color from the original pixel, we can find the distance between this color and each color on the Rubik's Cube, which we already plotted here. The color with the shortest distance from the pixel will be its closest match. If we run the calculations for each color, we can see that the closest match is orange. We can now switch this pixel to that color and repeat this for every single pixel in the painting. This process is called image quantization, and as you can see, it looks okay, but compared to our original image, it has some issues. The differences between these images can be minimized by a process called Floyd-Steinberg dithering. Say we calculated that the closest color to this pixel is orange. Beyond calculating the error, we can also calculate the error vector, or the distance between each of the red, green, and blue channels separately. The next step of Floyd-Steinberg dithering is to multiply each coordinate of the error vector by 7/16, whose product we will add to the right pixel's RGB individual values. Note the decimal points are just rounded. We will do the same to the pixel directly below it, except with only 5/16 of the error. Normally, we would distribute 3/16 of the error to the pixel at the bottom left, but since there isn't any, we can skip that, and just distribute 1/16 of the error to the pixel at the bottom right. But why specifically these numbers? Well, the main idea is that these numbers add up to 1, ensuring all of the error is diffused, and these numbers are also just proven to work the best. Now we repeat this process again with every pixel, and the end result looks much more like the original picture, at least much more than the image quantized one. As the input image gets less and less pixelated, the overall appearance will, inherently, get more and more like the real image. Of course, some colors like black or gray will simply just be impossible, because there is no black. The closest color is dark green, which is why some aspects, such as her hair and clothes, which normally have black in it, have a heavy dark green tint. A sneaky way around this is to tear off the stickers of a Rubik's Cube to allow black to be used, which heavily expands the amount of colors that can be in the artwork. But in my opinion, this kind of destroys the authenticity of the mosaic, the idea that only 6 colors contributed into the entire art piece. And green doesn't look so bad anyways.